Good morning, viewers. Good morning, students. This is Supreme Education Foundation Schools, Year 11 Mathematics class. The topic we're going to be looking at today in our video lesson series of probability is listing outcomes in probability. My name is Mr. Ayodeji Ogunye. I'll be your tutor for today. So let's get right to the lesson for today. At the end of the lesson today, students, you are meant to be able to list outcomes from two events. You are also meant to be able to use sample space diagrams to list outcomes in a logical way. Welcome to class, everyone. I believe everyone is available in class today. So please make sure you pay attention to the lesson so that you can capture every area of this lesson today. All right, let's get right to it. We'll start with a game. We have a 2-dice bingo. The instructions are: choose 6 numbers to put in your bingo card. Then click to roll the dice. 2 dice are rolled, and then the scores are added. If the total matches one of your numbers, it is crossed out or crossed off. Now see how many rows it takes for you to cross off all your numbers. Okay, let's get to the game. I'm gonna choose a few numbers. I'm gonna go for 6, I'm gonna go for 8, I'm gonna go for 9, I'm gonna go for 7, I'm gonna go for, let me go for 11, and then let me go for 5. These are my numbers. Now let's roll. Oh, the first row I have 1 crossed off. Second row, third row, 2 out. Okay, all right. Okay, I think I'm very good at this. I chose very good numbers. Okay, just 10 rows and 5 out of my numbers are gone on my bingo card. Okay, bingo. I was able to make 16 rows. Interesting. So guys, you could play this game as well. It's kind of interesting. When you get to do your assignment, you can actually click on the video lesson and play the video, play the game as well. Okay, enjoy. Let's move on. In the last game, we rolled 2 dice and added the scores, okay? Some totals came up more often than others. All right. And then we discovered that when we were clicking on it to roll the dice. Okay, how many ways are there of getting a score of 5? Now, what do we mean by this is there are times in probability questions that when we have 2 events, maybe you are trying to roll 2 dice at the same time, the question we'll be asking you will be something of this nature. You know, what is the probability of getting a score of 5? That means the score that shows, okay, on the first dice added to the score that shows on the second dice, okay? What is the probability of getting such score? So we need the number of ways, okay, such that the addition of the number on dice 1 to the number on dice 2 will give a score of 5. This is an example right here. The first dice showing 1 and the second dice showing 4. So 1 plus 4 gives a score of 5. I think we have more. We could have 4 on the first dice and 1 on the second dice. We could have 2 on the first dice and 3 on the second dice. We could have 3 on the first dice and 2 on the second dice right here. That addition will give 5. So it means there are 4 ways. 1, 2, 3, 4. There are 4 ways in which you can achieve a score of 5 by rolling 2 dice. So the probability, okay, that is just about listing outcomes for a score of 5. You know, the probability of any event is about the number of successful outcomes or number of required outcomes divided by the total number of possible outcomes. So here we are just showing us how to list, okay, required outcomes that they shall be asking us, or possible, successful outcomes that they can be asking us. So there's another example here of another type of successful outcome or required outcome. The required outcome here is getting a score of 7. So if I'm to get a score of 7 on 2 rolled dice, aha, you see it? There are 6 ways of doing that. 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 3. So since there are 7 ways of listing, of getting a score of 7 when you roll 2 dice, okay, you will discover that when we did a score of 5, the number of ways was not as much as that of getting a total of 7. So please take note of that, guys. You need to know how to list outcomes. All right, let's come here. Now, this is another very interesting way of listing outcomes. We can list all the totals for 2 dice. Now, the very first aspect we talked about is when you are trying to get your number of successful outcomes or your number of required outcomes. We've dealt with that already now. That is how you get it, okay? But we can also plot a table like this or create a table like this to actually show us all the totals that are possible, okay, on the 2 dice. That means we're trying to get our total number of possible outcomes. So of course, the first box right here, we can just tell ourselves that we want to, okay, we have 1, 2, 3, 4, 5, 6 on the blue dice and 1, 2, 3, 4, 5, 6 definitely on the pink dice. If we roll a 2 on the blue dice and a 5 on the pink dice, so the blue dice came up with a 2, the pink dice came up with a 5, the sum is going to be 7 right here. The addition of 2 plus 5 is going to give us 7, or 5 plus 2 is going to give us 7 right there. Okay. Now, this table has been filled for us for all the totals. We want us to fill in the rest in this table. Of course, you know that if I add up, this is 1 plus 4, and that should give us 5. This is 2. That goes, okay, that goes together. The box is under 1. So 2 plus 1, so that should give us 3. And then here, I have 5 plus 2, and that should give us 7. And then here, this is 6, and then the other dice is having 1, so 6 plus 1 is also going to give 7. Let's mark it. Well done. All correct, guys. All correct. Now, can you notice that there are 36 possible outcomes in this table? Now, what do we mean? If you look at all the totals that we have, all of them, when you count 1, 2, 3, 4, 5, 6, blah, 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 you would have counted 36 possible outcomes. Okay, that's all the numbers on the white space boxes. But then there is another way, which we're going to show you very quickly in the course of the lesson, that another way you can actually, most of the time, quickly know the number of possible outcomes for your outcome. For example, if you look at all the numbers, okay, if you look at all the numbers that you have for your pink dice, you will notice that, okay, you will notice that there are how many numbers there? Let me do that again. You're going to notice that there are 6 numbers that you have here for the pink dice. And if you check for the blue dice, you also notice that you have how many? 6 numbers as well. So we tried the multiplication rule of outcomes. 6 numbers on pink dice, 6 numbers on blue dice. Multiplying 6 times 6 will give you 36. That's a very shortcut way of getting your total number of possible outcomes. when you are dealing with two events of this nature. So guys, take note of that. Instead of just counting, just multiply 6 times 6. You get 36, which is the total number of possible outcomes. Okay, now let's move on. So we have that. Now, moving to the next stage, we, of course, here again is a table of outcomes for the two dice. We have a few questions. What is the probability of getting a total of 5? Okay, the probability of getting a total of 5 is actually 4 out of 36. How did we know that? From the table. So sometimes the table is actually very fast in getting the probability because you have everything right in the table. Your total number of possible outcomes is everything, all the sums. And then you can also pick your required from here. You can pick your required. We've done this already before without the table. Remember, we already mentioned that there are 4 ways of getting a total of 5. So 1, 2, 3, 4. So that is, they are showing us that in this table as well, that there are 4 5s in the total, in the possible outcomes of totals. Okay, so the probability is 4 over 6 over there. Now, take a look at this, guys. This is still the pink dice and the blue dice rolled together. We want to find the probability of getting these scores. Okay, to get a score of 4, I'll just come to my table, which totals here give us 4. This is 4, this is 4, this is 4. So how many do I have? I have 3. 3 4s. 1, 2, 3. Okay? 1, 2, and 3. So that means there are 3 successful outcomes or required outcomes for getting a 4. But the total number of possible outcomes definitely is 36. We know that already. To get a score of 10, that's a total of 10. 1, 2, and 3. You can see it here. I have 3 of them. So there are 3. So 3 over 36. Now I also have for more than 9. To get a score more than 9. Now, when you have more than 9, that's greater than 9. Don't forget that. So that means 9 is not included. So just totals that are more than 9 or greater than 9. So I have 1, 10 is greater than 9, 11 is greater than 9, 12 is greater than 9. So when I count, I have 1, 2, 3, 4, 5, then 6. So that is 6 out of 36, the total number of possible outcomes. Now for a number less than 4, for a score less than 4, for a total less than 4, this is 4 right here. Totals less than 4 will be 3 and 2, so 1, 2, 3. So that's just going to give us 3 over 36. Once we mark it, all correct. Well done, guys. Let's move on. Now, in the next, we have 2 spinners, A and B. You want to decide whether each of the statements is true or false. Oh, we're taking us back to remind ourselves about the words we use in probability, the likely, unlikely, equally likely, certain, uncertain, which is impossible. So let's see how we can work with this. Scoring 1 is more likely on A than on B. I told you before in the previous lessons that when you want to work on this, you need to calculate the probabilities of those 2 spinners. That will help you to get it very fast and pick your answer. So if I quickly work on the probability of, the probability on spinner A, I want to calculate the probability of getting 1, the score of 1 on my spinner. Okay, probability of 1. This is going to be equal to what? All you just need to do is 1 is the required outcome on your spinner. Okay, so how many 1s do you have on your spinner? How many 1s? 1, 2, 3. Okay, there are 3 1s. And then what is the total number of numbers on this spinner? Okay, so you have 1, 2, 3, 4, 5, 6. So there are 6 numbers here, out of which 3 are 1s when divided by 6. That should give us 0. Okay, let me just reduce it first. That's 1 over 2. And then in decimal, it gives us 0.5. So the probability of getting a 1 on this spinner A is 0.5. Let's check that of B. Let's check that of B. I'll put it on this side. I'll use a different color for that. Let me use green. The probability of getting a 1 on dice B is going to be equal to, well, total number of numbers on this spinner is definitely 3, 1, 2, 3. But how many ones are there? Just one. So we expect the probability to be 1 over 3. And if we take that down to decimal, we're going to have that to be 0.3333. Okay, so let me just use 2 decimal places for this. And then I'll use 2 decimal places for this as well. Just put a 0 to make it 2 decimal places. All right. Now, guys, compare the two probabilities. 0.5 on A, 0.33 on B. Which one is closer to certain? Which one is more likely? Okay, remember on your table, on your line that we call the probability scale, certain is to the right, impossible is to the left. So which of these two numbers is close to certain? Because close to certain is more likely. And of course, we know 0.5 should be the one that is definitely close to certain. So it means that to score 1 is actually more likely on A because the probability supports that than B. So this is true. Okay. It says that is not right. Scoring 1 is more likely on A than on B. More likely on A than on B. Let's check our calculations again. 1, 1, 1. Okay, that's 3 out of 6, which is 0.5. And then 1 over 3. There are 3 here. 1 in spinner B. Okay. Oh, sorry. We are right. It's supposed to be true. Apologies. It's supposed to be 2 because the statement is actually right. That's what we're talking about. Okay. So the probability of 1 on spinner A is 0.5. The probability of 1 on spinner B is 0.33. On the probability scale, to the left is impossible, to the right is certain. So which one of these two probabilities is actually closer to certain? Definitely 0.5 is certain. You know, on that probability scale, impossible is 0 and certain is 1. So 0.5 is closer to 1, okay, than 0.33. So the statement is going to be true for this one here. Let's take a look at scoring 2. Scoring 2 is more likely on A than on B. Is that true? So let's check for 2. So we're going to look at this and talk about probability of 2 now. For the probability of 2, of getting a 2 on this first spinner, how many 2s do we have on spinner A? If you look at it very well, you will see that you have 2 2s on spinner A. So that should be 2 out of 6. So if that is the case, I have 2 over 6. 2 over 6 should reduce to 1 over 3. And 1 over 3 in decimal should give us 0.33. Let's go to spinner B. Spinner B also, we want to have the probability of getting a 2. If you look at it closely on spinner B, you will see that there are total number of 3 numbers, and then there is only 1 2. So this should be 1 out of 3 as well. And so it still remains 0.33. Oh, the probabilities are the same. To get a 2, a score of 2 on both spinner A and spinner B. So that means the statement is supposed to be equally likely. But that's not the statement here, so this must be false. Yeah. We'll move on to the next one, scoring 3. The probability of getting a 3, okay, if you have to get a 3, a score of 3, how many 3s do I have on spinner A? There's just 1 3. So that is 1 out of 6. So I'm going to change that to 1. And 1 out of 6, definitely we can go straight to its decimal. The decimal is going to be 0.1 out of 6. That's 0.16666. So I'm going to just go 0.17 to 2 decimal places. And then for the probability of a 3 on this die is still 1 over 3 because there's just one 3 and there are 3 possible outcomes. So the 1 over 3. So let's see. Which one is closer to, let's see the question. They are talking about, oh, no. The question is talking about, the statement is talking about equally likely on A and B. The probabilities are definitely not equally likely. So definitely this is false. All correct. Well done, guys. We move on to the next stage. Here we have 2 spinners. They are spun. The table shows the sum of the scores. We want to fill in the gaps. Now you know what it means now. Spinner A is here horizontally, spinner B is here vertically. To fill in the table, we are just adding the scores together. So here should be 1 plus 1, which is 2. Here should be 2 plus 2, which should give 4. And here should be 3 plus 2, which should give 5. Now let's find the probability of getting these totals. Now we are going into probability now. The probability of getting these totals, number 1, a total of 6. It means that the number of required outcomes or the number of successful outcomes, our success is a score of 6. So how many 6 did I or can I see in my possible outcomes? Well, I can see just one 6. So that is 1 for the probability over what? Over the total number of possible outcomes. Remember, the total number of possible outcomes can be gotten simply by multiplying all these ones, how many on spinner A and how many on spinner B. On spinner A, obviously, as you can take a look at it, okay, we have 3. No, we have 6 on spinner A. We have 6 on spinner A, okay, and then on spinner B, we have 3. So you can easily just do 6 times 3 to give you the total number of possible outcomes, or you can just count. But doing the multiplication is quite faster. So I can see here that the total is actually 16, total number of possible outcomes. So I'm going to come here and then, put in 18 rather. 6 times 3 is 18. I'm going to put in 18. The next one, a multiple of 3. So you need to count. All right. How many multiples of 3 can you see in your sample space? That's the total number of possible outcomes. I have 1, 2. Okay. This is the first one. There's the second one. Multiple of 3, like the 3 times table. That's 2, 3, 4, 5, and 6. There are 6 of them. So I have 6 out of 18. And lastly, an even number. 1, 2, 3, 4. Oh, pardon me, I skipped 4 in the first row. So 2, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, 9, and 10. I was able to count 10. Let's see if I am correct. Of course, total number of possible outcome is 18. If you mark it, all correct. Well done, guys. So that is how that goes. Moving on. Here, we have a spinner that displays 2 animals at random from this selection of frog, cat, and dog. What is the probability of getting a matching pair? Okay. The first thing we want to do is to perform an experiment to estimate the probability to find out using this picture match. So let's try to take the record of the result by using tally for this chart. So we're going to be writing the numbers down. When it matches, we record. When it doesn't match, we record. So in this way, we can spin and see the match that can happen. Spinning once, it didn't match. The second time, we have a match. The third time, not a match. The fourth time, not a match. Fifth time, not a match. Sixth time, there's a match, cat and cat. No match, cat and dog. No match, cat and frog. Match, frog and frog. And then I have no match because it's frog and cat. That is on my 10th spin. Now, we already know from previous lessons that for us to get a good estimate, okay, a good estimate, we must do the experiment a higher number of times, a lot of times. Okay, that is the only time we can get a very good estimate. So in that case, the more we do it, the better the estimate will be. Between 50 and 100 should be enough for the estimate we're looking for. But let's just go for the 100. So that means I have the option here of spinning 10 times at once. So we click on that. So that will make me, I did 10 at first. Now I've done 20 just by clicking on spin 10 times. I've done 30, 40, 50, 60, 70, 80, 90, and 100. So I have 100 spins now. And the result I have is 38 matches and 62 that didn't match. The probability we are trying to calculate is of getting matching pair. So required outcome of the successful outcomes that we have for matching is 38. So that will make our probability of match, okay, is supposed to be equal to successful outcomes, 38, divided by total number of trials, which is 100. Okay, so this is successful trials, that match is 38. Total number of trials is 100. So I think this should be 0.38 when we take it to decimal, 0.38. So for estimation, we have been able to get the probability as 0.38. Okay. So let's move on. 0.38 for matching is the probability, the estimated probability from the experiment. Now, what if we now do a proper calculation, okay? This is what we are supposed to do. We create a table. It's quite always very easy when you create a table when you have a pair, okay? When you have pairs of probabilities. So here we have frog, cat, dog, frog, cat, dog. When you put it together, this should give you frog, frog. This should give you frog, cat, or cat, frog. This should give you dog, frog, or frog, dog, depending on the way you want to look at it. Okay, so when you fill in all that, you use letters to represent F for frog, C for cat, and D for dog. So frog, frog, cat, frog, dog, frog, and you know what the rest means. FC is frog, cat, 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 dog, cat, frog, dog, cat, dog, and then dog, dog. So using that, you can see the pairings that are possible. This is pairing 1, FF, pairing 2, cat, cat, another pair here, dog, dog. But the total number of possible outcomes is definitely going to be how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 over there. Like I said, you could do 3 times 3 to get that easily. That is 9. So the probability is going to be 3 out of 9 because we have 3 that matched. 1, 2, 3. 3 out of 9 possibilities. And 3 over 9 is 1 over 3. Remember that we can still write this in decimal. So 1 over 3 in decimal should be equal to 0.33 to 2 decimal places. So that simply means that to answer their question here, how does this compare with your experiment on the previous page, page 7? You will see from the previous page, I still have our result here. Can we compare? Look at the 2 answers, okay? So the first one that I have here is from the calculation, but the second one here is from the experiment. Can you see that they are very close to each other, 0.33 and 0.38. So that should tell us that we got a match about a third of the time. If not, it may have been because of the low number of spins. So that means if we increase the total number of trials in our experiments, our result here will even still be much more closer to 0.33. So that was a wonderful one. Very good. Okay, let's continue. Now we have another type here in a class. There are 3 boys, Alan, Bob, and Charlie, and 3 girls, Debbie, Elaine, and Fiona. They are standing for the school council. A boy and a girl are picked at random from this group. What is the probability that Charlie and Debbie are picked? First of all, we need to list all the possible pairs that can pick, that can be picked. Can you list what you think they would be? Okay, guys, that's a class activity for us to do. Okay, that is a class activity for us to do. But based on the previous examples that we've treated so far, let's take a look at that. So we need to fill in these places. So this is how you could set up your table. Alan, Bob, Charlie, those are the guys, the boys. Debbie, Ellen, Fiona, those are the girls. You can see what happens here. This is a pair of Alan and Debbie, Alan and Ellen, Alan and Fiona. So filling in the rest, guys, fill it in, fill it in, fill it in, fill it in. I'm sure you would have gotten Bob and Debbie, Bob and Ellen, or Elaine, Bob and Fiona. And finally, you have Charlie and Debbie, Charlie and Elaine, Charlie and Fiona. Those are the pairs we have. Now, if you take a look at everything, you see that there are 9 possible pairs. We could have gotten that by 3 times 3. And one of these is Charlie and Debbie. The question was about Charlie and Debbie being picked. So where is Charlie and Debbie? Okay, right here. This is Charlie and Debbie right here. Do we have any other Charlie and Debbie? No. So there's just 1 out of the total of 9 possibilities. So the probability is definitely 1/9. Well, I've explained this already that there are 3 choices for the first person, 3 choices for the second person. So 3 times 3 can always give us the possibilities overall. It's what we call product rule for counting. For counting, okay? Product rule for counting. So that works for us. To find the total number of possibilities, just multiply the number of options for each of them, and then you get your total number of possibilities. Then the next thing we have to talk about is you have to make, this is an example now, a practical situation. I want us to work on this, guys, as our activity for today. You have to make a sandwich, okay, made of some kind of protein and some kind of salad, and also some form of sauce. Now, these are your choices. You have 3 choices for protein: chicken, salmon, and beef, or beef, rather. Chicken, salmon, or beef. You have 3 choices for salad: lettuce, onions, or tomatoes. You also have 3 choices for sauce: tomato ketchup, pesto, or mustard. You are not feeling so hungry, so you will not have more than 1 type of salad, protein, or sauce. So for example, if I want to make my salad now, my sandwich rather, I can't take more than 1 of this. I can't take more than 1 of this, and I can't take more than 1 of this to make my salad, to make my sandwich, okay? So let's say I decide to choose chicken with onions and with tomato ketchup. That's what I can pick, just 1 to make my salad. So what I want us to do right now is, can we provide the total number of possible outcomes, okay? Set up the table, or you can just write it out if you want. Show us, okay? All right. On the Edmodo page, while you're watching this video, I've dropped a link for you in the chat section, okay? I posted it on Edmodo. That link is my Padlet link. So just, you know the drill. Click on the link, it takes you to my Padlet, and then give me your outcomes. What you can do, let me give you a hint for that. To make life easier for us, we abbreviate the ingredients. So chicken as C, salmon as S, beef as B, lettuce, onions, tomatoes, LOT, ketchup, pesto, and mustard, KPM. Okay, so I'm going to be expecting that one of the possibilities, I'm going to type that out now. One of the possibilities that we can have for my sandwich, I mentioned it, I could have chicken, I could have onions, I could have ketchup. So chicken, onion, and ketchup. This is a combination for my salad, my sandwich rather. So guys, I need to come up with all the possible combinations that you can get to make a sandwich with these ingredients. Remember, you can only take one from the pairs, okay, at a time. You can't choose chicken and salmon at the same time. It's just one from here. So you could make a table to create that. You could also make, just go through it if you know how to do that. So basically what I'm telling you right here is such that, you know, you could have done this and this 3 times 3 to give you 9. So you know you have 9 possible outcomes, but I have more than 2 events. There are 3 events here, okay? There are 3 events here. And those events are protein, salad, and sauce. Protein, salad, and sauce. So definitely, I'm going to expect that the total number of possible outcomes should be 27. That is 3 times 3 times 3. So guys, get to the work. Put it on my Padlet. Let me see your results. And then I would mark it and tell us if you are correct immediately. So guys, I believe we have come to the end of the class for today. I hope you enjoyed the class. Please do the classwork, drop it on my Padlet. It has to be done during the class. So by the end of the class, by now, this is just about, 40 minutes. So you have 20 minutes. The class is for 1 hour. You have 20 minutes to get this together and post it on my Padlet. I will see your results real time as you are posting it, and I will comment on them immediately. So guys, thank you very much for watching. I'll see your classwork done on my Padlet, and I will see you in the next class. Thank you very much. All right, guys, bye for now. And then we're going to see again in our next class. Please remember the link has been posted for you already on my Padlet. I mean, yes, for the Padlet, it has been posted for you on Edmodo. So make sure you go there and you do your classwork. Send it to me very quickly, and then I'll respond immediately to mark your classwork. Thank you very much once again, and I say bye for now. Bye, everyone. See you in the next class.